In this tutorial, we are going to learn about energy transfer in a rigid tank system. Please read the example question before you follow this video tutorial. A saturated liquid vapor mixture at 100 degrees Celsius is contained in a rigid tank. The quality of the saturated liquid vapor mixture is 0.123. The final temperature becomes 150 degrees Celsius by a heat transfer process. Let's summarize the given information. We have information of initial phase of the system and initial temperature of 100 degrees Celsius. And the final temperature is 150 degrees Celsius by a heat transfer process. However, we do not know the final phase of the system yet, and the volume of the system remains 10 liters because it is a rigid tank. In order to find the heat transfer, we start with energy balance and energy transfer equation from the first law of thermodynamics. Using the given information, we can confirm it is a closed system, therefore no energy transfer by mass flow. It is also a stationary system, so there are no kinetic and potential energy changes. Also, there is no mechanical device inside the system, so there is no work transfer for the system. When we apply all information to the energy balance equation, only remaining terms are internal energy change and heat transfer. So heat transfer for this process can be found by internal energy change in the system. In order to find the initial internal energy, first we need to find the mass of water in the rigid tank. Using the given initial quality X and saturation table A4, we can calculate the initial specific volume. Then we can find the mass of water by total volume over the initial specific volume. Continuously, we can find the initial internal energy per unit mass using the initial quality with saturated liquid and vapor values in the table A4 as well. In order to find the final internal energy, we must understand the final phase of the system. Since the final temperature is given, the final specific volume is the same as the initial specific volume. We can compare the value of final specific volume with the values of specific volume at the saturation temperature of 150 degrees Celsius using table A4. The final specific volume is actually less than the value of saturated vapor condition. Therefore, final phase is still saturated liquid vapor mixture. To find the final internal energy, we need to find the quality X for the final condition. Using the final specific volume and saturated liquid and vapor values from table A4, quality X of the final phase can be found as 0.525. Then we can calculate the final internal energy per unit mass. The final internal energy per unit mass is 1643.5 kilojoules per kilogram, and the initial internal energy per unit mass is 675.76 kilojoules per kilogram. From the previous slide, we got the mass of system and the initial and final internal energy per unit mass. Simply plug it in into the energy equation, and then we can find the heat transfer in of 46.8 kilojoule for this process.